One of the key features of Image and Biotech's service is our own specially designed data workbooks, which form the basis of how we return data to our customers. I am now briefly going to go through how to navigate and use these workbooks so you can get the most out of the data package we deliver. When you first open the workbook, the Experimental Details tab will be selected. On this page is a green box which contains the basic information about the experiment and any comments relevant to the results contained within. You will notice that towards the bottom of the page is an index which contains a list of hyperlinks that will take you to the other pages within the workbook. For example, if I click on the plate maps hyperlink, then I am taken to the plate maps page where the plate maps used in the experiment are shown. Each independent variable for the experiment receives its own plate map. So for this particular experiment, there is a plate map for cell line, for compounds, for compound dose, and finally for sample repeats. I can quickly return to the index page by clicking on the Return to Index hyperlink, which is located at the top of every data page. The type of pages present in your data package will depend on the options you chose for your study. If you opted for us to plot the data, then immediately after the Experimental Details page will come tabs with all the graphs we have prepared from the study. I will click Graphs Calu 6 and now you can see the graphs for this cell line. Returning to the index, the next important pages are the statistical summary pages. These are always included, even if you opt not to have graphs with your data. Clicking on the statistical summary page takes us to a series of tables, actually pivot tables of the data. At the very top of the page is a small table that contains the various filters that can be applied to the data. At the moment, the filter is set to cell count and cell line H292. I will now change it to PEGFR and Calu 6. You will notice that as I change the filters, the data in the table also changes. Below the filter table is the first data table, which has the doses in the far left column, and then each compound in the columns moving from left to right. Compound 1, compound 2, and so on. In this experiment, we had 2 samples, so each compound occupies 2 columns, one for each sample reading. The statistical summary table appears immediately below the sample table. In this table, the mean and standard error of the mean for each sample has been calculated. It is this table that forms the data behind the graphs we saw earlier. If we return to our dose response graph for Calu 6, you will see that the first 3 compounds are coded blue, green, and red. These data are shown colour-coded on the statistical summary page: blue, green, and red. Each value, here in orange, represents the Y value of the reading, while the standard error of mean column, in purple, determines the length of the error bar. The yellow column determines the x-axis values. So from this table, the user can filter the data to generate their own graphs in whatever graph package they prefer. If we scroll below this final table, you will notice an Excel graph of the data. This graph is live in that it will automatically update when you change the filters at the top of the page. And you can see this now as I change the filters. This graph is included independently of whether your study includes us returning the data graphed. This particular workbook also contains an extra statistics page where the dose response data is normalised against the zero dose control, and this is done with an extra normalised table, as can be seen here. Note, depending on the complexity of your experiment, we may return to you workbooks with several different statistical summaries, each consisting of different pivot tables that divide the data into blocks for graphing purposes. You may have noticed the plus sign on the statistical summary page. If you push this, then another table is revealed. This table is the actual Excel pivot table of the data, and you should normally not interact with this table, which is why we hide it. However, if you understand Excel pivot tables and are an advanced user, then you can also modify this table directly to control how the final data is summarised in the statistical summary table. For example, let's say you want to remove compound 2 from the dataset. Clicking on the compounds drop-down arrow reveals the compound list, and now you can simply deselect compound 2. You will see that all the tables have now been changed so that compound 2 no longer appears in them. Or let's say you want compound 5 to appear first in the table. Clicking on compound 5 in the pivot table and then dragging it to the left reorders the compound list for all the other tables. Remember, these are all advanced pivot table functions, and most of the time you will not need to worry about them, so in general it is best to keep the raw pivot table hidden. I will now do this by pushing the minus key. Let's now return to the index page of the workbook. The next hyperlink, Images, will take you to a page where example images are displayed if you have chosen to receive images as part of your study package. Note, we may also choose to give you images as part of a PowerPoint file, depending on the image resolution. We shall now return to the index page. We have already explored the plate map page, so the last page to look at is the flat data file page. This is the most important page of the whole workbook, for it is here that all the independent variables of the experiment are associated with the dependent or measured variables, which I'm showing in green, are associated with the measured or dependent variables, which I shall show in yellow. No matter how many independent variables there are, each is coded within a separate column. So here we have cell line, compound variable, dose variables, and so on, with each measured variable occupying a series of rows. So the measured variable cell count is in the first row, and if we scroll down, we begin the second measured variable, which is phospho-EGFR, shown here. If we scroll down, we come to the third measured variable, which is phospho-EGFR, different tyrosine site, shown here. Data in this format can easily be imported into most statistical packages. Likewise, one can apply filters at the top of the data to select subsets. For example, H292, compound 1, and cell count filters can be set, as shown. Returning to the index page, you will notice again another plus key. shown here. Pushing on this gives a final list of pages which constitute the raw data pages for the experiments. If we click on Total EGFR, we are taken to a page which has the actual numbers that came directly from the array scan read. These numbers are the ones that are associated with the independent variables information on the flat data file page, as shown here. Thus, the workbook contains a complete audit trail from the raw data as obtained from the array scan right through to the finalised graphs used to visualise the data. We hope you enjoy using Imogen Biotech's unique data workbooks, as we believe the data structure we have developed is the most comprehensive solution at handling the complexities of high-content analysis experiments.